All right, so tip sheet for the 10th worksheet, dealing with pedigrees. Pedigrees is like a family tree that geneticists use to help track a specific trait throughout generations within a family tree. They represent males with being squares and females by being circles. If you have a shaded in square or a shaded in circle, that means you have the genetic disorder. So based on that, you can kind of backtrack generation after generation so that you can figure out who's giving what gene. This one is all about albinoism. That's where your skin pigmentation doesn't have anything. So it's almost like a pinkish color. So if we were looking at the genotypes that were given for humans, what would the phenotype be for someone who is dominant A, dominant A? Now, looking at here, dominant A up in the top, dominant A equals normal skin cells or skin pigment. Little a means you are an albino. Okay, so if you are big A, that means you're normal skin. If you are big A, you are also normal skin, but you're considered a carrier for that trait. And then, of course, if you're little a, that means you are an albino. So based on that, big A, little a, and little a, you can fill out the trait below. Now remember, shaded in shapes mean you actually have it. So you can immediately, dad is an albino. So that means dad's genotype is little a. Mom, on the other hand, she does not have a shaded in mark. So we know immediately she has at least one dominant gene. But the other one, well, it could be a little a or it could be a capital A. The only way to tell is they got married and they had 1, 2, 3 kids. Each kid has to get one gene from each parent. So that means this kid is going to get a gene from mom or from dad, which is little a, or it could be little a. So that means it has to be a little a. So that means mom has to give either this one or this one. Okay, well, this one right here is a capital A. That means that child has normal blood or normal skin, which she does because it doesn't have. This one is the same concept, A or this one. So that has to be A because it's got to be a capital because it doesn't have it. And then dad can only give little a's. But the last one, dad has to give a little a, which means mom has to give one of these two. Well, if she didn't give her that one, because she is an albino, so that means this one has to be a little a. Does that make sense? Let's do one more. This one, when you answer the question, how many children does this family have? Well, that's dad, that's mom. They have 1, 2, 3. They have 3 kids. And what are the sexes of the children? Circle, circle, circle. That means they are all female. You can try this one on your own. It's pretty straightforward as well. But sometimes there are questions. So let's do this one right here, okay? Immediately when you're looking in anything that has a shaded color, you can immediately go ahead and fill them in with recessive traits. Because you know, in order to be an albino, it has to be homozygous recessive. And you automatically know that all the ones that are clear have at least one big A. Now the trick is to figure out what the missing gene is on all of these. So if dad and mom have normal blood and they have 2 kids, remember, they each have to give a gene. And if they have a child who is an albino, that means mom and dad both have to have that recessive gene. So big A, little a, big A, little a. So which, well, it doesn't really matter. One of the parents gave them the capital A. So this one is still kind of up in the air because it could be either or, so we're not really sure. So we move over to this one. This son married a girl. They married and they had 1, 2, 3 children. We have to figure out what their missing genes are based on their kids' generation. And as you can see, that one's big A, that one's big A. But they also had an albino child. So if they have an albino child, that means both dad and mom have to be heterozygous because each one of them have to give a gene in order to be little a, little a. So we move to this child who is, ignore that mark. This child is big A something, and this one's big A something. Well, again, there's so many options and possibilities for this one, you can't really tell. But this child, this girl, married this boy who was an albino, and they had one kid who was also an albino. So that makes this one, well, if that came from that parent, this one has to come from that parent. So that means this child has to be little a. But when we're talking about this kid right here, again, it could be A or B. The only way you can really tell what this missing gene is when they get married and they have kids. And then depending on what their kids look like, then you can possibly tell with that. So this one right here, I would just leave A with an actual question mark because it could be either one. Now let's ask, how many children does the original couple have? Well, this is the original couple, so we can say that's generation 1. This is generation 2. This is generation 3. This is generation 4. So the original couple is here. How many kids did they have? 1, 2. Remember, this person was married in. That's what that is. So they had 2 children. How many grandchildren does the original couple have? Well, they have 1, 2, 3. Remember, that person's married in. It's not really their grandchild. So we have 3 here. And then what are the sex of the grandchildren? Well, you have female, female, and a male. Oh, great-grandchildren. So this is grandchildren, so this would be great-grandchild. So the great-grandchild is a female. Hopefully this makes sense to you. This last question, we're all about lab rats. Manny is the male, and Manny had a litter of mice with April, June, July, and May. So follow the tracks, figure out what they are. Remember, immediately, solid ones, you can put little a, little a. Clear ones, at least one of them is going to be big A, and then you got to figure out what the other one is. Okay, this one, be patient. Don't go fast. You make mistakes. Call me if you have any or email me if you have any problems. Thank you.